In this lecture, we'll have a look at the most basic model for analyzing panel data and the estimator of this model, which is sometimes called the pooled OLS. The setup for this model is that I have a stationary and balanced panel. As an example, we can look at Spanish dairy farm production. This dataset consists data from 247 farms over 6 years, from 1993 to 1998. We assume that the panel is stationary, and by that we simply mean that when we consider any time series for any variable or any farm, such as the number of cows in farm 1 between 93 and 95, then such time series are assumed to be stationary. Just a reminder, YIT is the notation for the dependent variable. In this example, it will be the dependent variable for farm I at time t. The first explanatory variable denoted by x2, then we use I, t, 2. That's the first explanatory variable for farm I at time t. In this particular example, I could use the milk production as my dependent variable, and explanatory variables could be things such as the number of cows, size of land, how much labor and feed that is used in a given farm at a given year. For this type of data, it would probably make more sense to estimate it as a log-log model and use the log of milk production as the dependent variable and the log of the other variables as explanatory variables. So given this data, I can specify a simple linear regression model as follows. Milk production in farm I at time t is determined by a linear function of several explanatory variables and an error term. So the idea behind this linear regression model is simply that we treat each row as a separate observation. So in the linear regression model, we simply ignore the fact that this data is a panel data. There are absolutely no problems doing that, and the same results as we are used to still holds if the explanatory variables are exogenous, that is, if the error term has a conditional expectation of 0 for all farms at all points in time, then the OLS estimator will be unbiased and consistent. To do the OLS estimator using panel data is straightforward. You simply do the same thing as when you do OLS in a cross-sectional model or a time series model. Here I have imported the data into eViews, so I could do something like this quick estimate equation using log of milk as my dependent variable, explaining that with a constant explanatory variable. I can use log of cows and perhaps also log of land. You can obviously include feed and labor as well in the regression. I just want to illustrate the principle. According to this result, increasing the number of cows by 1% will increase the production of milk by about 1.3%. We also know that as long as the error terms are homoscedastic and not autocorrelated, then the OLS estimator will be efficient as well. Plus, the standard errors will be consistent and all the inference will be applicable. So running a simple OLS on a panel data, completely ignoring the structure of the data, is sometimes called pooled OLS. Just to emphasize what I mean by ignoring the structure of the data when we do pooled OLS is simply that we don't use this information at all. I could, for example, reorder this entire Excel sheet any way I like, and I would get exactly the same OLS estimators. In later lectures, we'll see that pooled OLS is actually not a very common estimator to use when we are dealing with the panel data. To understand the reason for that, we need to discuss something called the error component model, and that will lead us to alternative estimators for panel data called the fixed effect estimators and the random effects estimators.